In the previous development log for Trial of Nio, card in the corner if you have not seen that video yet, I went over some of the game's lore and story and mentioned the next log was going to be focusing mainly on the Softlock detection system for the game. I have a feeling this one is going to be a bit longer than usual given how much there is to cover, but before we go deep into it, I should probably define what I mean by Softlock. Generally, a softlock is what happens when a player cannot progress further into the game and has to manually reset. Some people define a softlock a bit differently, for example in Super Mario Maker 2. If you trap a player in a space in which they cannot get out, but you have a way for them to die within the box, then it's not considered a softlock, since they have a way to reset without either waiting for the time to run out or manually resetting the level. A softlock in Trial of Nio is similar to that and is basically you have done something which makes it impossible for you to get to the end of the level. So let's get a layout from one of the earlier levels to use as an example for what I mean. The way I label levels when I'm making them on paper and in engine is the starting room is 0, the ending room is -1, and all other rooms go up in honestly a pretty arbitrary increment until they reach the end. Between the numbered rooms is a door. The player transitions between rooms generally only through doors. So the player starts at room 0, goes through door 0 to 1, and enters room 1. If the door was closed and no way to open it was available, getting to room 1 would be impossible, which ultimately means getting to room -1 is impossible, so the player is softlocked. With that idea as my starting point, I tried to figure out the best way to represent that concept programmatically, and I decided to use nodes. In the scene, I would make sure each room I build is given a node which corresponds to their number, and each door would serve as a gate from one node to another. Each gate would have two states, open and closed, to represent the current state of the door. After all the nodes and gates were created, I needed to make a function that would start at node 0, and by going through gates, find any combination of non-repeating rooms resulting in a valid path from wherever the player's current room is to node -1. Just track which room the player is in with an integer and you should be able to find a path. There was a huge flaw in this first attempt though. The door's default state is always to start closed, meaning as soon as the level would load it would flag as being softlocked because the door from 0 to 1 was closed. So it's not enough to simply check if the door is opened. You also have to check if the door can be opened, otherwise it will constantly flag itself prematurely. As I mentioned in development log 2, click on that card above to see that one again, doors open exclusively when they are powered, so I would need to make a list of all power sources connected to the door and define how I could check if they are valid or not. Depending on the type and number of connected power sources, the door may need more than one type of check. First, I have what is effectively an event power source, an invisible object that opens based on a condition, like a voice clip reaching a certain point or something scripted in the level finishing. Basically, every level's first door from room 0 to 1 is an event door, so in terms of the softlock checking function, if it sees a closed door with only an event power source, it will treat the door as if it can be opened every time. Then we have things like the standard button, which is a static object that can supply power when pressed. Here is where we run into another problem. So if the door is closed and the standard button is in the same room, no problem. From this viewpoint it's not a softlock because you are in the same room. But if the button is in a different room, now we have to figure out if the player can get from the room they are in to the room the standard button is in to open the door to see if the room can be unlocked. So we need to make a path from that room to the room the button is in through doors. What this means is a logic right now to check if a door can be opened so we can get to another room requires us to know if we can go through potentially another unrelated door to another room. This is bad and is very likely to end in an endless loop and crash. So I had to come up with a way to avoid this situation, or at least dramatically decrease the chance of this resulting in an endless loop. I started by changing the nodes to have two different types of gates, entrances and exits, meaning I can easily tell which direction I'm going through the nodes in the code. This also meant I had duplicates of gates. For example, from room 0 to room 1, I would have an entrance gate for room 1 and an exit gate from room 0. I decided there to make the gates twin so they would share a state, but have opposing directions, again for the sake of ease of use later on. After that, I start dividing this main check function into a series of smaller functions, starting with what I'm calling the initial gate check. The initial gate check just goes through all the gates and has the option to label them one of three things: valid, invalid, or validating. Valid for doors that are opened already, and validating for doors that presently are not open and need to be checked. While it can label a door invalid, it does not do so here. After we've done that, we assign a node as the current node, meaning whatever node corresponds to the room the player is in at that moment. From there, we move on to the secondary gate check, which starts from the current node and creates a queue for every connected room to check via both exit and entrance gates. If the node number has been checked already during this instance of the softlock guard, it skips over it to avoid duplicates. Depending on the gate's label, different logic is applied. Valid and invalid basically just results in a bool version of themselves. Validating is where all the power source specific checking logic starts and decides ultimately whether it is valid or invalid. So here's where we go back to the standard button path validation. I created another function called getAllValidPaths, which basically just returns a data class containing two lists. One list of integers for all valid room numbers, and a list of integers for all valid paths from point A to point B. The reason this path check doesn't have the risk of looping infinitely like the previous one is because we treat all validating doors as invalid. In other words, if the doors are not specifically opened, it is considered closed. That sounds kind of stupid saying out loud, but it makes sense. With the path data, we can do a simple check for the standard button. If the list of integers paths has at least one path in it, it is considered valid. Otherwise, it is invalid and the door is considered invalid as well. Then we have the pressure buttons, which on paper seems like they would use similar logic to the standard button, but there is another variable which makes them more annoying. The Siphon Cubes. In the first development log, you know where the card is by this point, so click it. I mentioned a scenario where if you freeze a pressure button while a Siphon Cube is pressing it, and then throw the cube out of the room and unfreeze the button, you would trap yourself. In order for the Softlock guard to know that, it needs to make not just a path to know if you can get to the pressure button, but also know if the total cubes you have access to is such that you can even use it in the first place. On paper, this doesn't sound that bad, so let's just block it out real quick. You have a pressure button, a door, and a cube. Since the cube, button, and door are all in the same room, we don't have to do any path finding for this door and we can say it's valid. Now, let's say we take that cube and move it back a room. Is it still valid? Yes, obviously. You can still bring the cube back to that room and the button is still in the same room, so it is still valid. If you throw the Siphon Cube into the next room and then the door closes, though, you can't get the cube to put on the pressure button to then open the door. It is invalid. So for this to function, do I have to keep track of every position of every Siphon Cube and make paths for all of them? Well, no. It is easy enough to just have each room keep track of every Siphon Cube contained within it, so if you move it to another room, the main room will say there are no more Siphon Cubes. But if you move the Siphon Cube to a previous room like before, how do you check if the Siphon Cube is valid for that other room? Well, with the getAllPaths function, actually. The data class it contains has a list of all valid rooms from your current position, so you could just check all the Siphon Cubes in those rooms to see if there's one that you can use for that particular room's pressure buttons. However, there is a problem there, because what if the cube is already opening a door and you can't take it to that room? Do I have to keep track of every button's current state in each room to calculate this? Again, no, I just check the power sources in each room. Specifically, I check how many pressure buttons are in those rooms in relation to how many Siphon Cubes there are. If the total number of Siphon Cubes is greater than or equal to the total number of pressure buttons, then it's valid. Otherwise, it's invalid. So, if there are 2 cubes in the starting room and the next 2 rooms each use Siphon Cubes, the Softlock guard will know the path is valid because the cubes can get from the current room to the next room to the next room. However, unlike the other 2 power sources, the pressure button has to take into account if the player has access to their time manipulation ability or not, since at the start of the game you'll not have it and unlock it after some more standard trials. So this works fine for the early levels but needs to be slightly modified if the ability is unlocked. Instead of adding up the Siphon Cubes and comparing them to the pressure button count, you can just check if any of the rooms have a single Siphon Cube in it. Since all pressure buttons can be frozen to be fully pressed, a single cube existing in a path is enough to say that it's a valid source. The last power source is basically an electric arc receiver, and I'm gonna be honest, I have not fully completed this one's softlock detection yet. The reason is because Siphon Cubes can be opened using void abilities and become an electric source object, which means all Siphon Cubes have to be taken into account. And the logic for checking if you have enough Siphon Cubes to make an arc taking into account all electrical sources and electrically chargeable objects in a room requires a more room-specific softlock guard system rather than the main one I'm using for the general path softlock. I will continue brainstorming effective ways to make this work and update its progress, most likely in a future video. So, once all the power sources are determined and their validity is known, the Softlock guard does its final path check, going from the player's current room towards the end of the level. If it finds a path, then the player is not soft-locked and nothing happens. If the player is already inside the end of the level room, the soft-lock guard doesn't search at all, because by definition you can't be soft-locked if you've completed the level. Otherwise, if it cannot find at least one valid path, it flags the player as soft-locked, Niall will say something condescending, and the level will reset. The last thing I had to decide for this was, when should these checks occur? Every time the player changes rooms? Every time a Siphon Cube changes rooms? Every time a door changes its state? The answer to all these questions is yes, but only when conditions like that are met. All this path making and looping through lists does not need to go on every frame, or really even that often during gameplay. If the player for some reason stays in a room for 10 minutes straight and doesn't change anything, the guard doesn't need to check for updates. In summary, every time the player or a Siphon Cube changes rooms or a door changes state, the softlock guard triggers. It checks every door in the level to make note of which ones are open already and which one needs to be checked. It then makes a note of which room the player currently is in and then validates each closed door based on its connected power sources. Once they are all validated, the softlock guard checks if a valid path exists, and if it doesn't, it tells the level it needs to reset. This is the first half of a two-step system, the level softlock guard and the room softlock guard. The latter of the two is going to be much, much harder. I don't expect to have a full update for that one too soon, but stranger things have happened in this project's development so far. For now, I'm going to mainly be doing a bit of art planning, getting those Eldritch themes I want figured out a bit more, as well as the final designs for the game's enemies, which will have a lot of similarities functionality-wise to the portal turrets, but a bit different. I also need to start thinking more about the sound design and what kind of music I need to start working on for Trial of Nile. It is definitely not my strong suit, so that probably will not be happening anytime soon. I'm not exactly sure what the next development log will be about, but I will keep you posted when I do. If you found this video or the progress on Trial of Nile interesting, consider subscribing to this YouTube channel and following it on Twitter for more development-related updates. If you have any questions about this project or in general, leave a comment below and I may be able to provide further assistance. Also consider joining the Mark of Doom community Discord and following the Mark of Doom Reddit page. I would like to increase the interactivity I have with people watching this project's progress so far, so feel free to join and be a part of the discussion. That is all for now, and remember, all is nothing, nothing is all. The first star's corpse hides a phantom gaze.